Hello and welcome to the TED Talk of us working on ORSAT, the skeleton version of ORSAT 0.
Okay. Okay, so start with a square. But I'm assuming it's square, right?
Mm-hmm.
The bottom. So what I would start with is in the top left, so you're in your thermal tab in the top left. Yeah, hit that one. And then actually before you do that, escape out of that command. You see where it says preferences and there's a little arrow.
What general region? This one? There.
Yeah, that arrow. Can you click that? And you just want to make sure that your units are where you want them. So like your length is in meters, that's fine. If you want to put it in millimeters, if that makes it easier for you, but you probably want to leave it in meters because it's going to be easier to define lengths if it were in millimeters. But when it comes to like entering like conductance values and stuff, then it'll get confusing. I would change temperature to Celsius just because I hate the conversion. Joules, seconds, kilograms, kilometers, that all looks good. You won't deal with pressure, force, or probably current or voltage, but you can leave those. That's always what I check first, just to make sure that I don't like get 80% through a model and realize I've been working in inches the whole time. And now you can exit out of this and you can go back to your square.
Where did you go again?
It's next to preferences at the top in the ribbon, and there's a little arrow. It's kind of hard to find, but that's where you go. And there's lots of stuff in here that'll be useful later, but for right now, units is what we just want to look at. So once you click the square, I don't like to use the GUI like as much as possible. So you want your origin to be probably at 0, 0, 0. So type 0, 0, 0. And then hit enter. I don't know if you've ever worked with AutoCAD, but like it's just way easier to do things with the command line. Now you want to put in your X size. So this is important because there's a global axis, but then every surface and geometry you make will have its own local axis. So you want to make sure you define this like according to the right-hand rule. Otherwise you're going to get confused later, because when you have a thin surface in Terminal Desktop, you can define radiation properties for each side. And Terminal Desktop is going to call one the top side and one the bottom side. And if you define this illy right now, then the thing you're going to think of as the top is actually going to be the bottom. So you want the X to be along the X and you want the Y to be along the Y. It's basically what that comes down to. So with this, what's the dimension? It's 10. What is it? 10 centimeters? 0.01 meters. So you're going to want to type in 0.01. What do you want to type in? Comma 0. Try that. To comma 0. So that's a coordinate on the global axis. So now you have to put in another. So we just went to the point 10 centimeters in the X direction, 0 in the Y. So now for the Y point, you want to go 10 centimeters in the Y and 0 in the X. So 0, 0.01. Yeah. 0.01. Then hit enter or 0.0. Yeah. And then hit right. 10 centimeters, right?
Yeah.
Okay. Then hit enter. Okay. This, it immediately pulls up your thin shell data. You can always come back to this, so it's not a big deal if you don't know how to define this. But for now, just make them edge nodes. So click the radio button that says edge nodes and just do a 4x4 matrix. So this is defining how many like temperature nodes you want on this surface. So just do 4 in the Y direction and 4 in the X as well next to it there. I don't know why I keep like pointing to my screen. You're not going to see that. Let's go. Okay.
I think I messed something up on the yeah,
you can change it here as well. So if you mess something up, it doesn't matter. And then in the comment section,
shouldn't it be 0.1, right?
Are you right? Am I wrong?
Yeah, 10 centimeters.
You're right.
Yeah.
Wait.
Yeah,
You're right.
10th.
10 centimeters is 0.1. You're totally right. Right.
Okay, that's it fixed now.
Yeah, 10 centimeters is 0.1 meters. Duh. Okay, so that's fine. You can hit okay. You can edit that later, and you will need to edit that later. So if you zoom in, do you have a mouse?
I do.
So click the mouse wheel. It'll reset your glass. If you click the mouse, not the mouse wheel, the scroll wheel, you know what I mean?
Yeah.
Like click it down. Is it not resetting? Do you have a scrolling wheel on your mouse?
Yeah, that's what I'm doing.
I
Do a
think
little
he needs to
hand.
double click, I believe.
Weird.
Oh yeah, that's weird. I remember
There it
double
is.
click
Yeah,
the mouse.
that's what I was looking for. Yeah, good call, Alex. On mine, I think it's a single click. Interesting. There you are. That's your. Go up to the top left where it says 2D wireframe. Do you see that? It's in the screen itself, not in the ribbon. So go down a little bit. Click that. And then go to custom visual styles at the top and click thermal. That's just a little bit nicer, I think. So that's your bottom face. And now you basically just want to enclose this, right? So the next thing I would do is make your, basically the ones that'll be coming out of the screen, same direction. So go ahead and hit the square again, or the rectangle there at the top. And again, don't rely on the GUI, rely on your own. So do 0, 0, 0 again as the origin. Like don't click anything, just type everything is what I would do. And then for this one, let's make the one that goes like along the X and then pops out. So for this one, you want your X point to be the same. So 0.1, 0. 0.1, 0. But then your quote unquote Y point is actually going to be in the Z axis. Because remember, we're defining a local coordinate system and we want our Z to be popping out in the right direction, because Terminal Desktop is going to call that the top, and we don't want our top to be facing in the interior. It's just going to confuse us later. So go ahead and hit enter here. And then for your Y point, you're going to want to go 0, 0, 0.1, because you want to go 0.1 in the Z direction for your Y direction. It's really confusing.
I think
That's like,
sense.
yeah, there you go. And then make another 4x4. Just go ahead and do edge nodes. You can do center nodes as well. It doesn't really matter. Another thing I would do is go over to your surface tab. And I would comment. So this is going to be your minus X face, right? Because we're on the lower. I would just always comment so that later you know which surface you're looking at, and then hit OK. And now try to orbit your view. And you should see, I think if you hold shift and click the mouse, yeah, there you go. There it is. So we made a right angle. Now you just need to do that same thing, but for all of them. And what an easy thing you can do for the top one's really easy. In fact, the other opposite side's really easy too. Oh, except no, it's not, because of the right hand rule. But for the top one, you could click the face you already have. Or for the bottom one, yeah. Yeah, are you selected on the side as well? I can't tell. Are you only selected on the bottom? So go ahead and select the bottom face and type copy in the command line. And then hit enter. And then for your base point, type in 0, 0, 0. So this is basically taking a reference point for your base, and then you want to hit enter. And then you want to copy this exact thing up to the point 0, 0, 0.1. That's just going to copy this face and move it up 10 centimeters. Then hit enter, and there's your top face. Now you can hit escape. So there's that. Now for the rest of these, I guess you'll just have to type them in.
You
So-
copy this one?
Yeah, you can copy that one, but the problem is, and I think I just realized with the bottom face, this might come back to bite us also. So if you copy that one, it's fine, but just keep in mind that Thermal Desktop, like your surface is here, if you copy it, it's gonna still keep your top facing this way. Like your top isn't gonna suddenly flip. So as long as you can remember that, then it's fine to copy it, you know, it doesn't really matter, but. And there's no way that I know of to just like tell it to flip orientation. I wish there was, otherwise this would be a lot easier. But the long way to do it is just to click the rectangle again in the top left. And then basically go through the motion. So your next point, you want your bottom, you want your next coordinate not to be at 0, 0, 0. You actually want it to be at 0.10 because you want to grab that left corner there. Can I draw on your screen? Is that something you can do in Zoom or no? You can't.
Yeah,
do it.
you should be able to if you go into annotations. So view options, and then it should say annotate at the top.
Sorry if you can hear my cat in the background using her litter box.
Okay.
So you want to start, you basically want to start at this point, and oh my God, and you want to make this square. So that means that we want to start at this point. This is going to be our X point right here, right there. And then our Y point is going to be this one. So you're going to start at 0.10, hit enter. And then your X point is going to be at 0, 0, 0. This is the most mind-bending part of, for some reason, this always confuses me. So if you do 0, 0, 0 for your, oh, you're on the Y already. Okay, now you want to do 0, 0. Well, no, you actually want to do 0.1, 0.1. If you do Shift Tab, it'll take you back to the last one. There you go. So type 0.1 there, and then type 0.1 in the Z as well. And that should take you to this point. How do I get rid of now the stuff that I've drawn? I don't want it there anymore. Okay, here we go. Okay, now I guess just do the same thing, you know, the 4x4 will be fine. And then there it is. And you'll want to do, just for, yeah, you'll want to do the same thing on all of these. One thing you can do actually is copy and rotate. You can try that. I've actually never done it that way. I think I need to let her out. She's very mad. So if you copy that face you just made, like you did before. Yeah, so copy that. Move it from, yeah, so copy, set your base point to 0, 0, 0. So it should ask you for a base point in the command line. Yeah, and then hit enter. And then set your next point to 0.1, 0.10. Okay, so now hit enter. Now click that face you just made, hit escape first. It always assumes that you're going to copy multiple times. So now type RO and hit enter. So that's the rotate command. Now it's going to ask you for a pivot point. So we want our pivot point to be the 0.1, 0.10, because we want to grab that. We want to grab this bottom corner. Basically what I'm trying to do is to grab, oh, I can't draw anymore. We want to grab, oh, it's so hard without a mouse. We want to grab this corner and rotate it about here, such that, because right now Thermal Desktop says that this side is the bottom and the flip side is the top. We just want our top to be facing out so that it doesn't trip us up later. So set your point, yeah, hit enter for that. And then it should ask you for, I think you can type 180. I think it asks you for a degree to rotate by. And if you hit 180, it should flip it and then hit enter once you're done with the 180. And there it is. Yeah,
Right.
easier.
Oh, we're almost done with the cube.
Yeah, it's kind of confusing. Like your intuition is just to copy it, but it does just make it easier for yourself down the line. So now so what you can do now is like copy this one and just move this point to here, if that makes sense. So if you, you click it and then type copy in the command line and set your base point to 0.100, which is this point, right? And then set your next point to 0.1.10. So we're just going to translate from this point over to here. And then hit escape and then rotate that by 90 degrees. And you'll be golden from the pivot point of this bottom corner right here. So are you doing the rotate command? Yeah, so you want 0.1.10 as your base point. And then you want to rotate 90 degrees because it's a right-hand rule, so it's going to pull it that way, I think. It ought to. Hit enter and hopefully it works. There it is. And there's your cube. So now, to be honest, I'm not positive if this step is necessary. I could, but basically, I think what Termal Dekstop is going to do right now is treat these as 6 individual like cubes that aren't, or faces that aren't really connected. So what you might need to do is like zoom in and merge nodes. So if you zoom in right here on that corner, oops, keep zooming in more and more, and then orbit orbit sort of like this way so that we can see slightly the bottom of the cube as well. Yeah. So now zoom in on this corner node. There's got to be a better way to do this too. I haven't figured it out. If you kind of click your mouse around in there, you'll notice that there are multiple nodes. So you see how it highlights, but there's some node that's not connected. If you think about what we did here, we actually have 3 nodes sitting right on top of each other. And what we kind of want to do is to merge all 3 of those together because we want this to be one continuous, we want heat to be able to travel through this surface and up into this one. And I get the feeling that if we don't do anything here, then we might have a problem. But to be honest, I don't know. I don't even know if that's perfectly accurate. We might be able to just run the simulation without doing that, and it might just work. But for instance, like so I don't know the design very well. Is this bottom face like PCB material and this is aluminum?
Yeah.
Yeah.
So with that, we actually want to do something different since these are dissimilar materials. In fact, if you wanted to be really accurate, you would do this with all of them. Since these are similar materials, like in real life, there's some kind of clamping mechanism that's connecting these right here, just about. And so you really want to define a conductance value from this face to this face. Basically from this face to this face and this face and that face and that face. Because that's going to allow basically this node, or no, that's a bad example. It's going to allow this node to talk to this node on this face. I'm saying this a lot. That's probably confusing. But does that make sense? Because right now, these things might look like they're connected, like to your eye, but as far as the thermal model is concerned, they don't have any connection. There's nothing binding this bottom face to this face. And we want there to be a connection there. So just to give you an example of, I guess, what I would do, go ahead and click the contactor button right here.
Sorry to interrupt real quick. I have to head out. I think the host can continue the recording. Hopefully it won't end when I leave, but someone restarted. So
Okay.
Thank you, Danny, for all your help.
Yeah.
Bye,
Have
all.
fun getting your booster.
Bye.
Bye.
So if you hit that, so did you click it? I can't tell.
Yeah.
Okay, so now it should be asking you to click a from face, right? Is that what you see in the command line? Yes. So what you want to do is to click this bottom face, just like where your mouse is right now. So click that and hit enter. The way AutoCAD's command line works is it always asks you to do the first thing and then hit enter to move to the next thing. Now to click the two faces, you actually want to click this face, face over there, like over in this region, and the face over here. You want to click all the faces that this is connecting to. So you don't need to like shift click or anything. All you need to do is click them all. Sorry, let me erase all my straight lines that are just everywhere. And then once they're all selected, you would hit enter. There we go. Okay, so this is an important page. This is the contactor page. And right now, if you look at the huge picture on your right, you see that it defaults to a face-to-face connection, which is not what we're looking to do. We want to connect the edges of this square to the other ones. So right here, yeah, hit that drop down and change it to edge. Hit OK there. It doesn't matter. That thing's done. I don't know why they have that. So now you see here, this is the important thing I was telling you earlier about testing. It's asking you for a conductance value between these surfaces. There are two ways you can do it. You can do it by length, or you can do an absolute value. So in this drop down below, you see it says input value type, and you could do per area or length, or you could do absolute. Honestly, I don't know what this middle one is. I never select it. I just always go for the bottom one. The bottom one is, but it really depends on what you want to do. For this one, it might actually be better to do per area, per length, you know, because I have no idea what this value is. So go ahead and hit per length for now, and just enter a dummy value of 1 right here. You can always change that later. And then at the end, it's always important to click this button that says show calcs. So that's how you check what you just did to make sure you actually made the connection you want to make. So if you hit that, and then you zoom in really close, you will see, well, this is, you really can't see. All right, well, if this were, you might be able to see very faintly some yellow in there, and that's what you want to see. It works a lot better when you have a little gap. So yeah, I think I see some yellow. So you should see a little bit of yellow along all the edges, and that's telling you that you have just made a connection between that face and all of those faces that you see the yellow on. So just to illustrate, yeah, to illustrate this point real quick, go ahead and hit escape. I think you have to hit escape. Click the bottom face and type the command move, M-O-V-E, and set your base point at 0, 0, 0. And then move it down like a millimeter. So 0, 0, negative 0.001. So we're just moving it down in the Z. We'll move it right back. I just want to basically illustrate this point. Yeah, hit enter. Now it should move down a little bit. Okay, now zoom in. See those green little arrows? Could you double click one of those for me? And now hit show calcs again. So that little green arrow is symbolizing your, there it is. So there are the yellow connections you couldn't see earlier. And that's telling you that this face is thermally connected to those other faces, which is exactly what you want. So now you can move that back up a millimeter. Go ahead and click it and do the move command. And this time, you know, I'll just click it and type move, and then put your base point at 0, 0, 0, and then your reference point that you want to move up to 0, 0. Instead of negative 1 millimeter, just do positive 1 millimeter. So now it's back in place. And to reset graphics, you can double click that thing at the top, because see, it still has like these wonky little, it's because it doesn't re-render these live. So you need to like reset the graphics every time. So either you can double click right here, or there's a green button somewhere up here in the ribbon. I can't see because my Zoom thing is in the way. Oh, right here, this reset button. Either of those will reset your graphics so you don't see those annoying yellow lines anymore. There you go. So basically what you would want to do is something similar for every face that's supposed to be connected. Like for instance, these faces, these two aluminum faces, I'm assuming they're connected by some kind of bolt pattern, right? So you want to connect these two, you know, along this edge with a conductance value that is equal to your bolts and your contact. So you have physical contact of two aluminum surfaces, but then you also have bolts going through them. And both of those are going to contribute to your heat transfer at that surface. So basically you would go through that same exercise. I don't know if we want to do it now, that might be a little too much, but you would go through that same exercise with like each of these surfaces. So go ahead and do it again for the top surface, just so we can make sure we know what we're doing. So hit that top surface and then click that connector button. Contactor, sorry, not connector. And then hit that. Oh, whoops. Oh, it's confusing because I won't even explain it. Go ahead and hit that first and then click the top one and then hit enter. And then for the faces you're connecting to, click all 4 side faces. And then hit enter again. And let's just do the same thing here. So yeah, change that to edges. That annoying thing pops up. And then you want to just change that to 1 watt per meter per Celsius, which is actually a lot, but oh well. And then yeah, you can click show calcs, but I'm pretty confident that that's going to be the correct connection. Yeah, you see the yellow there. So now you're connected thermally there. Everything looks great. So I don't know how much time we have left. 15 minutes. And I also don't know how hard everyone's cutoff is. I know it was scheduled till 9, but you know, whenever, I don't know how far you want to get. Do you want to like actually run a simulation, or do you want to, you know, does this feel satisfactory?
So we've got, so I guess what we're missing now would be like heat loads, but I don't know if we want to go that in depth on it yet.
So heat loads I would add later. Well, actually it depends what you mean by heat loads. So like internal heat loads from electronics I would add later. But you're right in that what the main thing we don't have right now is we don't have a heating environment. So there's no simulation to run right now because I have nothing to simulate. I haven't put this cube in orbit. I haven't done anything that's actually going to simulate temperatures. And even if I tried to do that right now, it would throw an error at me because I have defined no thermophysical or optical properties. So if you're doing radiation, then you need to have optical properties defined. And if you're doing conduction, which you always are, you need to have thermophysical defined, which is your thermal conduction, your density, and your specific heat. So you need those things. And then on the radiation side, you need your absorptivity and your emissivity. So just real quick, go ahead and click.
Could we use the same values from the capstone?
Yeah,
Just import the values.
Yeah, if somebody has like the RCO and the TDP or whatever it is, those files, then we can just import those really quick, and that would be really easy. But I don't know if anyone has those. Does anyone have those?
I mean, I have them, but I think you could also get them straight from GitHub because I believe
cool.
they're
Is it a different? It was on a different version of Thermal Desktop too. So with that,
It shouldn't matter
no.
because they're separate files basically. They're what they really are is text files, but then they give them fancy extensions. They're just text files that like define your properties. So if you get those files from Git, they should have the file extensions RCO and TDP, I think.
This would actually be, I don't know how to use Git. I have it all set up, but
I don't know.
I only know how to take the entire library.
You can ask Marvin, he knows.
Yeah, I can let you teach you about that. I can also, for the time being, I can just send you the files directly on Slack. I'll
Let's
drop
just
them
do
in
that because it'll be quicker for now.
Here we go.
I've never really learned how to use Git either.
There we go. So I just dropped those two into the thermal channel.
Okay.
So now if you save those to any directory of yours locally, so just throw them in your downloads or documents or I don't know, wherever you want to throw them. And then let me know once they're there.
Also, if you need the symbols, you need to get them straight from the actual drawing.
You'll need the symbols. Oh, that's true. We need the symbols too, don't we? Because those files reference the symbols, don't they?
Yep.
Yeah, I thought so. Okay, so you need the symbols file also. Does anyone have the symbols file?
It's just the drawing itself.
Just the
Should
drawing.
be, I think.
No, there should be a file called symbols.txt. You know, it's a text file, I think, that defines all of your symbols. So if somebody has that, throw that in there too.
Yeah, so I just sent two files. There are two symbol files in the simulation folder right now. So I just sent both of them.
Okay.
And then there's also, yeah.
There's,
So go ahead.
there's 3.
3.
There's
So
one
save-
called symbol check.
Symbol check. Maybe
Symbol
don't.
unit check.
Maybe don't use that one. Maybe just use the one that
I tested this out already, and you could use a drawing file and it should give you all of it, but I believe you need all the files as well. So I don't know.
if you have the thermophysical file, the optical properties file, and you have the symbols file, then you should have enough information. So the only reason that you need the symbols file is because I defined my properties using symbols. This is like an extra step that maybe makes it more complicated, but it does make it easier for quickly changing things to like check things. So that's why you need all 3 of those files. And in principle, we could just like make the properties really quick, and maybe that would honestly be quicker. But
Yeah, and then we can have it on video of us. We'll just put in like the unit, like just one as the values for them.
yeah, you want to do that real quick?
Yeah.
That's really quick. So go ahead and click this thermo thing right here.
Well, okay.
We might as well actually put in aluminum just to make it somewhat aluminum. So did you click that?
No, I didn't. Click what?
This thermo button up here? You see that? Well, I'm trying to circle it, but yeah.
Can you only do brown?
Yeah, I don't know why it's so ugly. Oh, I can do red. That's great. That's way better. Okay, so you want to hit add or yeah. Okay, no, actually, you need to enter your name first. So type in aluminum. We're just gonna add we're gonna add aluminum, and then somebody look up the conductivity of aluminum. What is it, like 250, 251? Aluminum thermal conductivity. It's 88 to 251. Let's just put in 250. So for K, put 250, and that's in units of watts per meter per delta C. And then for the specific heat, I have no idea what the specific heat is.
For 6061-2 aluminum, the conductivity is 167.
All right, let's do 167 for K instead of 250.
Specific heat is 900
Perfect.
and density is 2700.
Good. So hit OK. That's all you need to do here. There's other stuff here, but that's too much in the weeds for now. So go ahead and hit OK. And then hit OK again. So now we're going to go to RC, to the optical properties here. And does anyone know what the emissivity or absorptivity of polished aluminum is?
Well, it's black anodized.
Okay, we can do that.
I have that value. Give me a
Yeah,
sec.
let's do black ano for now. Absorptivity is probably like 0.79 or something close to 0.8. I don't know. Maybe 0.9. I don't know what kind of anodization you have, but
The values say absorptivity 0.54
oh really?
and emissivity 0.75,
Interesting.
and that's
Alright.
it. The rest stay the same.
Yeah, then hit. Those are the only two big ones you need. Transmissivity is if you have like something that, you know, light can get through, but light's not going to get through aluminum. So and hit OK. Now you should see that. So go ahead and hit OK again, the bottom OK. Yeah, that red is a lot better. So now what you're going to do, so there's a neat little trick in AutoCAD where if you click from the right and select, then it's only going to select what you go over. But if you click from the left and drag your crosshair, then it'll select everything in your field of view. So click over here and just select everything. And then there's a couple of things you can do here. Either you can type in your command bar RC edit any, or you can hit this edit button right here. There it goes. Okay. So what we want to do, yeah, you want to edit the surfaces. So it's asking you, I found a few things here. I found surfaces, I found nodes, and I found contactors, but we want to edit the surfaces. So go ahead and select, it's already selected on surfaces, so just hit OK. And what we want to do is go to the radiation tab. And for top and bottom, just change it to black ano. I realize this isn't accurate. I'm sure that only, wait, why is that happening? I thought you named it black.
There's like a comment.
Oh, gotcha. Okay. Okay. Thank God. So that's good. And then in con cap, which is the next one over, don't touch the bottom one. I don't really know what that is, to be honest. You can change the material to aluminum. So now we did our radiation. This is our conduction. And change your thickness here to like, I don't know, how thick are those frames? Like 4 millimeters, 5 millimeters, 6 millimeters? I don't know. I realize that they have varying thickness, but just kind of estimate something.
The average thickness.
Yeah, average thickness is what we did for ours, I think. So that would work fine. Hit OK there. So now you should have radiation defined. Wait, what is this saying? Oh yeah, apply changes. I don't know why it does that. Now everything's defined. We have a connection. We can run this thing through a really simple orbit and call it good. So for now, at least. It's
So like a quick recap, we created the panels with the nodes. Then we connected them using the contactor. Then we edited them, click on them, edit, and then we added radiation and conduction.
Yes.
How did we where did we go to put in the we went to thermo and optical to do the properties. Then we assigned them. And now that's good enough to run a simulation?
Yes, there is. I'm debating if I should bring up one more thing. No, maybe I shouldn't. No, it's fine. yeah, we're good enough to run a simulation. We just need to actually define a simulation. So the thing I want to bring up is that, and this is something I actually kind of more recently learned, it's best to subdivide your radiation environments. So like out here, you're going to have the sun and the earth, and you're going to have all this, you know, solar radiation coming in. But the inside of this hollow cube sees none of that. So you basically want to define a radiation group for out here, and then you want to define another one for in here, because the inside faces of these have a view factor of 0 to any of these outside faces. It's okay if you don't define two separate like radiation analysis groups, but it makes it way easier to keep track of, and it also makes it less computationally expensive if you like parse those out. So if you define this as the exterior, oh, I can't type with this. And then in here you have a different radiation group called interior, basically. But we'll go over that some other time because I think that's going to take too much time. But for right now, we'll just keep them all in one radiation group, and we'll leave it to Thermal Desktop to figure out that, hey, the inside of this face has 0 view of this, the outside of this face, you know? It's smart enough to do that, but it's easier if you just tell it, hey, guess what? The outside of this face is not going to see the inside of this face at all. So there's going to be no radiation exchange between those two. There's going to be conduction, but there's not going to be radiation. But so what you want to do, how do I can't move my, yeah, what you want to do is click that, your orbit button. And then you want to add an orbit and just call it orbit for now. Like, I don't care. It'll be a basic orbit. Okay. Let's just, so now this is your orbit tab. Let's go, I don't know, what's the altitude of Orsat 0? Is
I
it
think
500?
it is 500.
Wait, what kind of orbit are you in anyway?
Basic?
It is basic. I mean, what kind of orbit is Orsat 0 supposed to fly in? Is it, did somebody said something about sun synchronous?
That's what I heard, but I'm not 100% sure.
Does the orbit
That's what
have
Andrew
any,
said, but that's all I've heard about.
we'll stick with basic for now. Sun synchronous basically just means I think that the orbital plane doesn't vary throughout the Earth's rotation. So in Thermal Desktop, it doesn't really matter. But does the orbit, do either of you know, does the orbit have any like eccentricity, or is it like pretty much a perfect circle?
As far as I know, it should be perfectly or almost a perfect circle.
Right. It probably is.
Yeah.
So go ahead and keep on the basic. Change the beta angle to like, I don't know. You know, actually cancel out of this basic one. Go ahead and cancel, because it's going to be easier, I think, if we did it this way. Add another one and do a Keplerian orbit and hit OK. And go ahead and do like an inclination of 20, I don't know, 20 degrees. And the right ascension, keep that at 90. I don't know. Or maybe we should go like 97. Go ahead and type 97 in there, and in the RA ascending node, not in that one. I don't know what that one is. I don't know orbital mechanics very well. Now I'll go to orientation. So we're at an altitude of 500 kilometers. Is that correct, or does it need to be lower? Is it?
I think that's right.
That's right. Okay. Orientation. Go ahead and put the minus Z axis pointing towards nadir. I don't know if that's accurate, but we'll just do that for now. In positions, so go ahead.
What is nadir? Is that a star?
Nadir is pointing towards Earth, correct?
Oh.
I think. So go ahead and go to positions up here. Start 0, 360, 12 increments. Change that to like 10 or 8. Change it to 8 increments. I don't need this to be a very good simulation. Yeah. and then go to planetary data. That should actually already be fine. It's like basically saying that you're orbiting Earth, right? Not like Venus or something. So keep that at Earth, and then in solar, keep that all the same. It's just defining the solar flux. Albedo, keep that the same. 0.35 is the average albedo value, so that's fine. Higher planet shine is probably fine. Everything else is fine. So go ahead and hit OK. I think we've fully defined this orbit. Go ahead though, and now do display orbit, because I want to make sure that I didn't make like a dumb mistake when I was defining this. I think I made a dumb mistake. This isn't what I was expecting. Because what does your orbital plane look like? I imagine it's something that's like almost polar. Like it kind of looks like, you know, like I imagine it kind of goes like this, right? Or does anyone know? No one knows. Well, let's just keep it like this for now. It'll change. I don't think that's probably not correct. Because I think usually sun synchronous orbits are like almost polar, so it'll be more like this. But that's fine. We can keep this for now. And now we do the important step of setting up our case. So up here in your case sets, see that button up there in your ribbon? Click that, and we're going to edit this case 0. You can add a new case also, but let's just edit this. And this is where basically we're telling Termal Dekstop what it's going to do for our simulation. So like, for instance, how long do you want to simulate for? Do you want a steady state simulation or a transient simulation? Since we're doing orbit, we definitely want transient. So go ahead and click that box and uncheck this one. End time. Actually, yeah, go ahead and do something fancy here. Double click this end time, like double click that field. And then in the expression, right click and go to orbital and do hour period right here. Can you see that? Can you see that? This HR period right here. Click that one. Yeah.
It was going underneath it.
Oh, shoot. And then hit OK, I think. Basically, what we're trying to do is run the orbit for one orbital period. So we're starting at 0 seconds and ending at basically an hour and a half is what that's going to translate to in hours, I think. And now go to the next tab over. This is the most important step, I think, in doing this. So hit add. We need to add two different tasks. So this is where we're telling Termal Dekstop what tasks it's actually going to run. And we want rad Ks. I don't know. Basically, okay, I need to explain this step actually. We want two different tasks. We want this one to start, and then we also want to add a heating rates task. This one right here is going to handle radiation between surfaces in your model. So if you didn't have this one checked, your faces would not talk to each other through radiation. So we definitely want to check that. Go ahead and hit OK. Now you want to add another one down there at the bottom. And for this one, you want to select heating rates. So this is the one that's actually going to pull in your orbit. So you see right here, you have the option to choose an orbit. Since you only have one orbit defined, it defaulted to your orbit. So that's fine. Monte Carlo is fine. So you can click OK there. So we have two tasks here. One of them is like calculating radiation between faces, and the other one is calculating radiation from the sun, from the earth, from albedo to deep space. And something that was told to me by someone, I don't know why, but I've done it ever since. This task right here, if you click it and edit it, the orbit task, you want to go to control up here at the top and change the raise per node to like 25,000 instead of 5,000. That's just what Steve Cole told me to do. And that's what NASA told him to do. So I do it. So that's, just leave that like that. It's just, I think it just makes it more accurate. So hit OK. It's fine. And now you can hit OK. That's actually, wait. No, I think that's fine. If you wanted to go back to that screen, you can hit edit. But I think everything else is fine. If you go to output, everything else should be normal. So yeah, go ahead and hit OK. And now all you have to do is press run one selected case at the bottom there. And that will actually run your simulation. This pops up because you have multiple nodes that have the same ID. Always just click the automatically renumber. You should only have to do this once and then it renumbers your nodes and then it shouldn't give you that error anymore. It's not even an error, it's kind of more of a warning. So if you click that, then something should start happening. And if the thing doesn't start happening, it means we missed a step.
Stuff is happening. You can't
Something's
see
happening.
it.
I can't see it. Okay, did like a screen pop up? Oh, there it goes.
Yep.
Perfect. So we officially ran this simulation, and just to check, zoom in on the screen. Where the heck is the actual satellite? So if you have a mouse wheel, double click it and it will like focus the screen for you. Did you double click? Yeah, there we go. So go ahead and click one of these faces real quick and click this XY plot. I just want to make sure that this simulation actually ran. You should get a plot of all the nodes. Hey, perfect. It's doing something. So you can see we started at the Earth is here. Well, actually, I don't remember what our orbit looked like, but see these huge temperature swings? I mean, you're going all the way from 30 to -15. It's because we have an orbit that's like literally going from, you know, hot side to way into the dark side. So you have some huge temperature swings on those faces, which is expected. So this is like performing somewhat like we would expect, and that's how you do the simulation. The next thing that would come is all the details. So like, for instance, first, the biggest problem is like this face is anodized aluminum, but the reverse face is not anodized, right? It's just plain aluminum. This isn't aluminum at all. It's a printed circuit board. So that needs to change. You know, now
The other face is anodized. The whole
it
thing's
is?
anodized. Yeah.
Is it black anodized on both sides?
Yeah.
It's very interesting. All right, well then ignore what I said. Both sides are anodized. That's accurate. And now basically what you do, like this top one needs to change to a printed circuit board. And then obviously this isn't just a hollow cube. So what you're probably going to want to end up doing is adding more nodes to all of these outside faces, because you're going to have to add card after card after card. And you want all of these cards to connect with these faces. So you want enough nodes to kind of accommodate that. So how many cards do you have in there? Does anyone know off the top of their head?
Hey, Marvin, you just put it together a bunch.
Yeah, I can pull up a photo and just quickly figure out. Let's see. Okay. Wait, no, that's not the right photo. Hold on a second. I know I have a photo here somewhere. There we go. 1, 2, 3, 4, 5, 6, 7.
7. Okay.
And then the end caps.
End caps. So you have like 9 in total, basically. So what you want to do, like way back when we first defined these faces, we gave it 4 nodes in this direction. But in reality, you're probably going to want about 9 nodes in this direction, because when you add those thermal contacts between a card that's sitting right here and all these edges, you want the nodes here to be pretty close to the nodes here for the most accurate model. You could imagine right now, if I did that, if I had, 7 cards sitting in here and I said, hey, I want to connect this card right here to this frame right here, then it's just going to find the nearest node and it's going to like latch onto all the way down here, which isn't like super accurate, right? So you're basically going to want to go back and like reseed these edges so that you have 9 or 10 nodes, maybe even more. Adding nodes doesn't increase the computation time by that much. So you're going to want to add a bunch of nodes in this direction and then add a bunch more frames. Then you want to add the PCB material, change all that. And then you can start actually worrying about what your orbit actually looks like, because that's probably not what your orbit looks like. And you can start adding heat loads and detailed, whatnots and all that. But yeah, that's about it. The only other thing I think I want to show you is that you can click this cycle time up here. Just click that real quick and go from time 0 to the last time. And if you hit OK, this does cycle through your temperatures. So this is kind of a nice tool. At least it's supposed to. I don't know if it's doing it right now. I can't see it on my screen. Yeah, there you go. You can change the rate at which that happens. That was like really fast. But you can you can play with, I think it's this one right here. And you can also, instead of the number of cycles, you can put it on a continuous cycle. And that's kind of a nice way to like get just a baseline of where your temperatures are at. But for the most part, I basically just use the XY plot, and then I pull that data and throw it in Excel, and then I actually do like my analysis. So that's the gist. You can hit escape to get out of this. It's just going to keep going forever, and then just hit yes or hit no. Doesn't matter. And that's it for now, I guess.
Yeah, I actually learned a lot.
Yeah, so hopefully that's enough to like add stuff to this and make it actually look like ORSAT 0, because I realize right now it's just a box, so it'll look better later. And then some other time we can talk about heat loads and all that stuff. Although Alex already knows all about heat loads, you can ask him about that. I'm sure he can tell you exactly how to do it. So that's that. I would like to at some point, because I'm pretty sure Alex, I never told you about this because I only just recently learned about it. I would like to at some point go over the different radiation analysis groups and how that should be dealt with. But everything else, Alex probably can tell you. So
Very cool.
that's all I got.
Yeah, so I guess going with that. So I don't know if you want to meet up, let's say at the same time next week. I don't know if just to do like an update of what we have and maybe see if you have any tips or whatever. Like a quick meeting, maybe like a 10-15 minute to see what we have currently and maybe give opinions of what we should do.
Yeah. Next week, this time. What's next Monday? You're talking to me, right?
Yeah, I'm talking to you.
Okay. Yeah, that should work. I don't see why not. And I'll actually be in Arizona at that time, so I'll be back.
Oh.
That's a lie. I won't be on your time zone. I'll actually still be an hour ahead of you because Arizona doesn't change with everything else. So.
I don't know if I'm going to be available yet. My work schedule doesn't go out that far.
Well, we can change the time. I don't care when. I will be on vacation this next week, so I'll be pretty available. So whatever works for you too, and or Marvin or Emmy, whoever is working on this, we can meet. And Alex, at some point, I want to figure out what's going on with the TVAC, but
Yeah, it's on fire right now.
Wait,
Are you
not
guys-
serious, right? I hope.
Do you know, like, is it something that's probably not going to be, like, how long do you guys think it's going to take to fix it? Do you think it's going to be like,
So Andrew wants it by February, or at least by like the beginning of by Valentine's Day, February, I think.
okay,
But I'm the only one working on it, so it's one-man job.
Mhm.
I'm gonna work with Glenn in the future, hopefully next week. Because I've been trying to meet with him, but he's always, busy. Or Andrew steals them from me. So yeah, I'd have to see. Right now the main issue is the roughing pump, since there's not a lot of information on it in regards to any type of cleaning or anything like that, since it's, I guess, already built as is. It's kind of strange.
Yeah.
Okay.
Yeah.
All right, so I guess we would need to ask either Marvin or Emmy about getting like the dimensions of the cards and whatever and the shrouds. And then one of us maybe built a replica of Orsat Zero. Maybe just the dimensions, maybe not the conductance values in it and all those things. And then maybe in the future start implementing the values found in the capstone project.
Yeah, start with like just the basic faces and then worry about your connections later. Because yeah, those will probably have to be found through a test if you want them to be accurate. So
Yeah, because in regards with the connections, I've seen that with like the solar cards to like the frames, you guys used node to node contacts, which I was
yeah,
confused because like wouldn't you want to use surface to surface?
if I did it now, I would probably use surface to surface. I'm not sure why we did that. I think the reason that we did that is because there were bolts, but that's a dumb thing to do because there are bolts, yes, but you're also pressed against the surface. So you definitely want to use surface to surface. I would not use single node to node contacts for that.
Yeah, because
It would
that's
be
what
a
I
dumb
saw.
idea. Yeah, sounds like something we would have done. Don't do that. Be smarter than that. Yeah.
Okay, so for next week, we'll kind of like, what I would feel comfortable being able to produce by next week would be a cube with the cards in it.
Perfect. Do the cube with the cards in it, and then also do surfaces for your solar panels.
Okay, yeah.
And they don't have to be. In fact, I don't recommend putting them exactly on this. Remove it a little bit. Doesn't matter. We'll worry about it on the back end. Honestly, it could be 5 meters away from your surface, and we could still make it work. Don't put it that far away because it'll be annoying. But like, offset it from the surface by a few millimeters, just so that
In
you
an
can actually see
aesthetically pleasing sort of way.
Yeah, so because later it'll come in handy if it's not actually like pressed on that face. It'll be better if it's slightly offset, and we can
Okay,
worry about that later.
sounds good.
Cool. Yeah, if you could do that, then I would say that's making good progress. And then, yeah, if we could meet next week, and then we can talk about other stuff.
Okay,
All right.
All right.
well,
That's
Merry
good.
Christmas to all.
Yeah.
Yeah.
Yeah. Have a good break. Happy holidays. All that.
Yep.
And talk to you next week. Or
See you
sometime.
guys.
All right.
All right. See ya.
See ya.